So today we're going to talk about complex numbers. So consider the number 5 plus 2i. Because 5 is a real number and 2i is an imaginary number, they are not like terms and you cannot combine them. Okay, so a complex number is a combination of a real and imaginary number. It is most often written in this form, a plus bi, where a is your real part, and then the bi, that's the imaginary. Okay, so we can add, subtract, multiply, and divide these complex numbers using different methods. So let's first talk about adding and subtracting. In this case, it is just combine like terms. So if I have negative 11 plus 3i plus 9 plus 2i, my like terms here is negative 11 and 9, and then 3i plus 2i. So negative 11 plus 9 plus 3i plus 2i. So negative 11 plus 9 is negative 2, and 3 plus 2i is 5i. This is your final answer. If you look at number 2, something a little bit more complicated, again, just combine like terms. However, we have to do some simplification here. So I have to distribute that negative. So I will have 6i minus 14 plus I plus 5 minus 3i. So my like terms are going to be the negative 14 plus 5, and then 6i plus I minus 3i. So negative 14 plus 5 plus 6i plus I minus 3i. So negative 14 plus 5 is negative 9. 6i plus I minus 3i is 4i. And that's your final answer. So now let's talk about multiplying complex numbers. If you remember whenever we talked about the powers of I, that I squared is equal to negative 1. So that is going to be helpful whenever it comes to multiplying. So whenever we multiply, you either need to distribute or FOIL, whatever you're given. So in this first one here, let's just distribute. So 2i times 8 is 16i minus 6i squared. Well, the I squared actually turns into a negative 1. So negative 6 times negative 1 is a positive 6 plus 16i. So remember that it has to be in the form a plus bi, where the real part is first and the imaginary part is second. Looking at number 2, this is an example of foiling. So 2 times negative 5 is negative 10. 2 times negative 3i is negative 6i. Negative 4i times negative 5 is positive 20i. Negative 4i times negative 3i is positive 12i squared. So remember that the I squared turns into negative 1, and you can combine these middle terms here. So you will get negative 10 plus 14i plus 12 times negative 1. Well, that just turns into a negative 12. So negative 10 minus 12 is negative 22 plus 14i. And that's your final answer. Let's look at number 3 here. This is a special one because we have a conjugate. A conjugate is whenever you have the exact same numbers. So let's say a plus bi. The conjugate is the exact same numbers, just the opposite sign in between. Okay, so instead of a plus bi, you have a minus bi. When it comes to conjugates, whenever you multiply them, the answer will always be a real number. So this is actually a way to get rid of your imaginary numbers, is multiply by the conjugate. So if we multiply here, 8 times 8 is 64. 8 times negative I is negative 8i. I times 8 is positive 8i. And then I times negative I is negative I squared. So the middle part, they will actually cancel each other out. And then the I squared is negative 1. So you will have 64 minus negative 1, which turns into a positive. So your final answer is 65. So the conjugate is useful whenever it comes to dividing complex numbers. So here's a couple of tricks. If your denominator is a monomial, multiply the top and bottom by I. So the reason that we're doing this is because we cannot have I in the denominator of a fraction. Okay, that's not mathematically correct. So if the denominator is a monomial, multiply the top and bottom by I. If it's a binomial, which means it has two terms, you need to multiply the top and bottom by the conjugate of the denominator. Okay, so that'll be example 3 and 4. But let's look at this first example here. I have 4 over negative 9i. So to get rid of the I in the denominator, I am going to multiply the top and bottom by I. So this will give me 4i over negative 9i squared. The negative 9 is going to now get multiplied by the negative 1. So remember, I squared is equal to negative 1. So we will have 4i over 9. No longer is there an I in the denominator, so that is simplified. Looking at number 2 here, again, I just multiply the top and bottom by I because my denominator is a monomial. Okay, it's only one term. So I'm going to distribute this I into the numerator here to where I get 28i minus 8i squared over 4i squared. Okay, so the I squareds all turn into negative 1. So negative 8 times negative 1 is a positive 8 plus 28i, remember the imaginary part goes second, over negative 4. Now, with this one, you can actually reduce. Okay, you can reduce each term here by 4. Okay, so 4 goes into 8 twice. 4 goes into 28 7 times. And 4 goes into negative 4 negative 1 times. So your reduced form is going to be 2 plus 7i divided by negative 1, which in turn comes out to negative 2 minus 7i. This is your final answer. So now let's look at whenever our denominator is a binomial. Remember, we have to multiply the top and bottom by the conjugate of the denominator. So here my denominator is 5 minus I, so its conjugate is 5 plus I. Okay, so whenever we multiply this, I'm going to distribute the 2 into both of those, so I get negative 10 minus 2i over. Now, whenever you are multiplying conjugates, a shortcut, since the middle part will always cancel out, just multiply the first and the last. So 5 times 5 is 25. Negative I times positive I is negative I squared. So I will have negative 10 minus 2i over 25 minus a negative 1, which turns into plus 1. So I will get negative 10 minus 2i over 26. And I can actually reduce each of these by 2. So 2 goes into 10 5 times, 2 goes into 2 once, 2 goes into 26 13 times. So your final answer is going to be negative 5 minus I over 13. Looking at number 4 here, again, multiply by the conjugate of the denominator. So we would have 2 plus 4i. And now we have to do some FOILing. So you can only multiply the first and last whenever you are multiplying a conjugate. 1 plus 8i is not the conjugate of 2 plus 4i, so you have to FOIL this out completely. So you will get 2 plus 4i plus 16i plus 32i squared. That is your numerator. Your denominator, however, you can just multiply the first and the last. So you get 4 minus 16i squared. Okay, so we can simplify this a little bit more. So we will get 2 plus 20i plus 32 times negative 1. That I squared turns into a negative 1. And my denominator here is 4 minus 16 times negative 1, which will in turn turn that into a plus. So 32 times negative 1 is negative 32. So I will have 2 minus 32, which is negative 30, plus 20i over 20. I can reduce each of these by 10. So 10 goes into 30 3 times, 10 goes into 20 twice, and again down there. So my final answer is negative 3 plus 2i over 2. And that's how you divide complex numbers.